Alright, for this exploration, problems numbers 1 through 6, we're going to do A, B, and C. Very similar like last time. Sketch, solve for y prime, rewrite y prime in terms of y. We'll do this part last because this one's going to be a little bit more difficult to grasp. And in order to emphasize, make this part letter D easier, place the number 1 a little bit higher than you normally would. To see the y value of 1, I don't know. For all my graphs, I'm going to place it a little bit higher than I normally would so it's easier to see what's going on your the sketches we're gonna make. I'm gonna show you how to make a new type of graph today. Not only that, but calculus with it. And it's all revolving exponentials. As you can see, I like exploring these exponentials right now. And let's see them in terms of y. Okay, exponential is now decay. Be careful, it's not growth. This one's decaying. Alright, y-intercept's the same. And horizontal asymptote of the x-axis. There it is, the y-intercept 0, 1. And this is the same function, however it's got a vertical shift of up 1. So now the horizontal asymptote is at y equals 1. Y equals 1 is the horizontal asymptote, and instead of having a y-intercept of 0, 1, because it got shifted up 1 unit, now it's 0, 2. And there's the same type of exponential decay graph. Alright, this is the same type of graph, decaying, but with a vertical stretch of 4. So now instead of passing through 1, it's going to pass through here at 0, 4. It's still decaying towards the x-axis. Vertical stretch of 4, right there. And then, notice how this is the exact same function, but with a vertical shift of up 1. So now it's going to pass through, instead of 0, 4, it's going to pass through 0, 5. And decay that way. Should look something like that. Alright? Alright, and then we got this right here. Same idea. This is exponential decay with a horizontal compression, but it's not shifted, so it's just go pass through 0, 3. It's got the vertical stretch of 3. Alright? And notice how this is the exact same function, but shifted up 1. Hopefully you see that pattern I'm trying to show you here. That's the type of functions we're going to analyze today. But not really. I'm going to start with those and transform them. Oh, 3e to the negative 2k. There it is. And instead of passing through 0, 3, because it's been shifted up 1, it's going to pass through 0, 4. Alright, now let's do some calculus. Here we go. So the first one is y equals e to the negative t. What's the derivative of e to the something? It's e to the same thing, and times the derivative of the inside, negative 1. Alright, and remember that e to the negative t is the same as that. So y prime is the same as negative y. But we've seen this before. This is just k times y. This is the directly proportional case scenario. We've seen that in the previous lesson. Alright. This is where you gotta watch out a little bit more, right? Be careful with this one. Y equals 1 plus e to the negative t. I'm trying to point out that this is just a vertical shift of that one. It's just been shifted up vertically, so the slope should be the same. Because what's the slope of a constant? 0. So the slopes of these two functions are the same. It's negative e to the negative t. The interesting part is, how do we rewrite this? How do we rewrite that one in terms of y? Well, let's analyze this a little bit more. The derivative is negative e to the negative t, but here we have positive. We need to manipulate this equation algebraically, right? So I would like to get negative e to the negative t, so let's subtract that on both sides. And to isolate that, we're going to also subtract y on both sides. I'm going to write it up here, or somewhere here on the side. We will get that negative e to the negative t is the same as 1 minus y. Again, I'm going to emphasize what we did is subtract e to the negative t on both sides and subtract y on both sides. We get this equation. And now we know that this is that. So y prime is 1 minus y. That's pretty cool, huh? And it's not a coincidence. This one's negative y. This one has negative y within itself too. Look, this is 1 minus y. This one's 0 minus 1. I mean 0 minus y, because the asymptote is at 0 here and the asymptote is at 1 here. Okay? Alright, let's go to the next one. Put a line right there to separate. Y is 4 times e to the negative t. What's the derivative of that? Derivative is 4 times e to the negative t times negative 1. Therefore, we have seen this again before. This is negative. Remember that this is the same as that. So negative y. Again, this is the k times y scenario from the previous lesson, directly proportional. This one's not directly proportional, alright? So that's a new scenario for us. And here we go, derivative of 1 plus 4e to the negative t. Same idea as before. This is just a shift of each other, a vertical shift, so the derivative should be the same. Negative 4e to the negative t. And y prime, let's write it in terms of that. So again, I'm going to think of that strategy where this is negative 4e to the t, but this is positive 4. Let's subtract this one on both sides, and let's subtract y on both sides. That's going to give us negative 4e to the negative t is the same as 1 minus y. Subtracting that on both sides and subtracting y, now we know that this is the same as that. So we can write this as 1 minus y. Again, we have seen that before, right? 1 minus y. Due to the vertical shift, hopefully you can see that. And let's go to number 5. I got number 5 next. Okay. And put a line here to separate. Then y prime is, this is a function. So this is e to the negative, well, I'm going to just write it as 3 times e to the negative 2t times something. What's the derivative of the inside? Times negative 2. Alright, and the reason for that is that y prime now is, look, this right here is the same as y. So this can be written as negative 2y. That's another cool way of writing a derivative negative, but we've seen that before. That's the k times y scenario, you know? Alright, last one down here. Okay, if this is y, then what is y prime? Remember that the relationship is this is just the vertical shift of that one, so the derivative should be the same. Negative 2 times 3e to the negative 2t. However, for letter C, the trick is to write this in terms of y, okay? So look, again, we have positive right here, and this one is positive. Therefore, all we need to do, this one's already positive, that one's already positive, just subtract y on both sides. So therefore, we're going to get that, I'm going to write it down here, that y minus 1 is the same as 3e to the negative 2t. You see that? This is the same as that, therefore we can substitute it in there. Negative 2 times y minus 1. This is perfectly acceptable. If you rearrange this, factor out a negative 1 from here, then you can write it as 2 times 1 minus y, which now fits that form as before. 1 minus y, we've seen that before, right? Yeah, pretty interesting with these vertical shifts. Alright, the next thing I want to show you is to sketch the graph of the reciprocals of these. And I'm going to use blue pen. So the main idea is I'm going to sketch by taking a y value and taking its reciprocal and plotting it on the graph as a new y value. Alright, so it's a little bit of a difficult idea to visualize. If at any point you're having trouble, just take out your calculator and graph them both. What's the reciprocal of e to the negative t? Think of it like, what's the reciprocal of 3? 1 over 3. So the reciprocal of this is going to be 1 over that, 1 over negative t. So what we're going to graph in blue is that equation, alright? And I'm going to think of a very special reciprocal. What's the only positive reciprocal whose reciprocal is the same? Kind of gave you a hint right there. Look, I marked it on the graph for us. It's 1. The reciprocal of 1 is 1. So that's where I would like to start. What's the reciprocal of 1? It's itself. Therefore, we know that both of these graphs will share that same point. They both pass through here, where the y value is 1. The next idea for this one, I want you to think. For example, this might be a number like a half. What's the reciprocal of a half? 2. What's the reciprocal of 1/3? 3. What's the reciprocal of 1 over 10? 10. What's the reciprocal of 1 over 100? 100. What's the reciprocal of a small number? A really big number. What's the reciprocal of something close to 0? Something really big going to infinity. And look, vice versa here. What's the reciprocal of 10? 1 over 10. What's the reciprocal of 20? 1 over 20. What's the reciprocal of a big number going towards infinity? It should be a number going to 0, all right? So the reciprocal of, these are big numbers. The reciprocal of big y values are small y values that go to 0. The bigger the y value, the smaller the y value is going to be for the reciprocal graph. And these y values are small. What's the reciprocal of 1/2? 2. What's the reciprocal of 1/4? 4. So the reciprocal of something small gets big. All right? There it is. This is y equals e to the t, to be honest. All right? And then there's one reciprocal. All right. This one gets a little bit more difficult to visualize due to the shift. Again, what's the only reciprocal that has that number as its reciprocal? 1. The problem here is there's no y value of 1, so I'm going to start with the point that I do know. What's the y value here? It is 2. What's the reciprocal of 2? It is 1/2. Therefore, the reciprocal graph, let's write that equation. Y equals, the reciprocal graph is 1 over this. 1 over 1 plus e to the t. Have you ever sketched something like that? No, we're going to do it for the first time. So here we go. The reciprocal of 2 is 1/2. So that's 0, 1/2. All right, and then these are all big numbers bigger than 1. What's the reciprocal of something bigger than 1? It's got to be something smaller than 1. All the y values are going to line up right here somewhere. And then let's use that other question. What's the reciprocal of something going towards infinity? Something going towards 0. So from here is gonna go towards 0 like that. And then it's gonna go up and it's approach something. Look, this is approaching 1. What's the reciprocal of something approaching 1? It's gotta be something also approaching 1, but it's gonna do it from the other side. It's got two horizontal asymptotes, 0 and 1. And all the y values below it for this graph. Okay, it's just a fraction always. 1 over a big number, it's always gonna be something small. Okay, all right, and this one we've done before already, something similar. I always like to highlight that y value of 1 because that's a good place to start. When the y value is 1, you know the graphs share that point. What's the reciprocal of 1? It's itself. So therefore I know that the graph of 1 over 4 e to the negative t passes through this point. And the other point I can use is this one. The y value is 4. What's the reciprocal of 4? It's got to be 1/4. And look, you can see that exponential is going to do that. What's the reciprocal of something going towards infinity? Something going towards 0. And you can visualize that exponential equation. All right, there it is. They're reciprocals of each other. And again, the interesting one I'm trying to show you today is the one with the vertical shift. So that reciprocal graph is going to be y equals 1 over 1 plus 4 e to the negative t. Have you ever sketched something like that? Probably not. So let's try right here. Oh, I forgot. This was 0.5 in the y value. You can verify that. If at any point you're struggling to visualize this, again, take out your calculator and graph them both. Graph this one and graph that one, and you can compare to what we're doing. All right. So again, I'm going to point out the graph never intersects the line y equals 1. Therefore, these graphs will never have a shared point like they do here. But we will use the same idea. We know a y value of 5. What's the reciprocal of that? 1/5. So this graph's got to pass through 0, 1/5. And what's the reciprocal of something going towards infinity? Something going towards 0. And again, we're going to see that this approaches 1. So therefore, it's got to go up and approach 1 like it did before, without crossing that asymptote. And again, you can see that's going to be the type of function that we're going to be sketching. It's a new type of graph you've seen before. It's got like a maximum slope right there, and then or point of inflection also. All right, cool. And again, I highly encourage you to watch these on the calculator if you need to. And then I feel like I should probably skip this one. I'm gonna just sketch it without explaining it. All right, this is gonna look like this. Cool. And let's talk more in depth about this one. This was the point. Oh, I did not label this. This is 0.4, I believe. Okay, and then again, notice that the graph never intersects the y equals 1 line. Therefore, they will not have a shared point, but they will have a shared vertical asymptote. I mean horizontal asymptote. We know the y value is 4 here, therefore the reciprocal must be 1/4. 0, 1 over 4. And again, it's going to have the same type of behavior. This type of graph is known as the logistic curve. If you want to write it down, this is known as the logistic curve. Just like we had the exponential curve, this one's the logistic curve, which we're going to do more in-depth research in a calculus manner. This is kind of cool, right? This is always going to be the point of inflection right there in the maximum, right? It's going to be one of the most commonly things that they're going to ask you about this. All right, so this is what we're here to explore today. It wasn't to explore this, it was really to explore this graph, which, as you can see on number 7, is what I'm trying to ask you next, is rewrite y prime in terms of y. And we have a couple of more examples leading up to what the general format might look like. All right, so that's coming up. All right, here comes the fun part. We got to rewrite y prime in terms of y. So y is, think of it as 1 over something. One of my favorite functions is 1 over something. What's the derivative of 1 over something? Negative 1 over something squared. If you prefer, you can use the quotient rule, but it'll take you longer to get there. Negative 1 over something squared. What's the something inside? 1 plus e to the negative t. What's the derivative of the inside? It's got to be negative e to the negative t. Yeah, this actually turns into positive. Negative times negative is positive, so if you prefer to put some little plus signs right there, I'm probably not going to do it in the future, but it's just e to the negative t. Alright, the goal is, how do we rewrite that, however, in terms of y only? Alright, this doesn't look close to it, but here's a hint right here, okay? Something square. Let's expand this square, alright? But what I mean by that is, let's write it as something, 2 fractions with the same denominator. One of them is 1 plus, or the same denominator is 1 plus e to the negative t, and 1 plus e to the negative t, which means this times this is the same as that, something square. And what I'm going to do is break up these factors. I'm going to factor this one to the first fraction, so it's 1 times that, and this factor right here, the e to the negative t, goes to the second fraction. And if you can verify, aren't these two things the same? Yeah, right? And we're closer because look, what do you notice about this in relation to that? Oh, it's exactly the same, right? So we can say, all right, we're getting closer. Y prime is y. This is y times some other fraction. This fraction right here. All right. Our next goal to do here is we need to be able to solve for e to the negative t, and we need to be able to solve for this expression on the denominator, the expression on the numerator and the expression on the denominator from our original equation. Alright, so visualize some algebra. We're going to manipulate here. Alright, to solve, the easier one to solve for is this one, the denominator. Because look, it's right there. To solve for the denominator, I'm going to multiply both sides of the equation by the denominator and divide both sides by y simultaneously. That's going to give us 1 plus e to the negative t is equal to 1 over y. Again, if you didn't quite see that, think of it like I'm multiplying both sides of the equation by the denominator and dividing both sides by y. Or just interchanging those places, you know, like that. And now I know that the denominator can be substituted by this. This is 1 over y now. Right? This is 1 over y, as shown right here. And the last thing to do is just one extra algebra step. How do we isolate this from here? Just subtract 1. So e to the negative t is the same as 1 over y minus 1. Right? Sorry, it's all crumbled up, but these are 2 different expressions up here. Whoops. Those are 2 different expressions, alright? But I just ran out of space. But hopefully you can follow that. And e to the negative t is just 1 over y minus 1. Substituting that in here, 1 over y minus 1. Now look, it's already in terms of y, but let's simplify this more because this is a complex fraction. So we want to undo this denominator. How do you undo multiplying by 1 over y? Just multiply by y. Alright, so y over y, or y over 1, you can think about it. And then y prime is the same as, this becomes 1. This y times 1 over y is 1, so we're just left to distribute this y into the numerator. And then we're going to get y times this one gives us 1 minus y. And there is y prime in terms of, look at that. Have we seen this 1 minus 1 before? Right? We saw it a bunch of times. But now it's times y, okay? So what I want you to think when you get to here is also that dy dx, the derivative I'm sorry, we're doing dy dt because most of these will be with respect to time. Dy dt, this depends on y only, and it's a product of y times 1 minus 1. That comes from this one. That's pretty cool though, right? That's a little bit more advanced than that one from before. Look at that. That one was a linear product. This one is a quadratic in terms of y, so I hope you can see that. All right, there's the first one. Let's do some that are a little bit more advanced. In my opinion, this problem is exactly like the one we just did, so we should probably skip this one, or I should assign it to you as a you try. I don't know, maybe I just want to explain it too in depth. Let's just go over it. Good practice, what doesn't hurt. So let's just, I'm losing a little bit of focus there. Alright, good practice does not hurt, so let's just go through the motions. Alright, we have y prime. What do you know about y prime? Because the function is 1 over something, we're going to think of it as the derivative negative 1 over something squared. What's the something? 1 plus 4 e to the negative t times the derivative of the inside function, or the something. That derivative is, again, a negative 4 e to the negative t, and hopefully you can visualize positive factors. Well, I don't know. I don't really like to do that, but they're both positive. And again, I'm going to use the same thought process as before. I'm going to break that into a product of two fractions whose denominators square can be just written as 1 plus 4 e to the negative t times itself. Oops, now I'm running out of space right there for that problem. Oh well. And this factor of 1 is right there. And now that one goes right here. And I feel like we did this already, right? Don't you feel like we've seen this up before? This is the same as that. So then this is y times some other fraction. And the question is, how do we solve for the numerator? How do we solve for the denominator from here? We can write that 1 plus 4 e to the negative t is the same as 1 over y. I just write this equation. I don't write the second one because I can just visualize it in my head. I can visualize the subtracting one, so this is 1 over y minus 1. And that one stays the same. This is just 1 over y, like we did in the previous problem. See, y prime again in terms of 1. Repeating the same process as the last problem. I told you this is the exact same process. We're going to get y times 1 minus 1. The derivative is that. Matter of fact, because I didn't show you this in the previous one, I'm going to show you that this can be graphed on a two-dimensional axis, where this is y prime. Think of it like this. The derivative depends on the y value, not t, not x. This is the y-axis and the y prime axis. And think of it a parabola in factored form. It has two factors. What factor makes this equal to 0? When y equals 0. What factor makes this equal to 0? When y equals 1. Therefore, now I'm going to ask, what kind of concavity? Because it's negative y, it's concave down. Does it have a maximum or a minimum? Looking at this graph, it has a maximum. Where does it have the maximum? When x equals 1/2. When when y equals 1/2. Sorry, see, common mistake. Well, it's not a common mistake. This is like one of the first times I ever made that mistake. Y equals 1/2. Boom. Nice, right? Because it's a parabola. Awesome. Nice little connection there. All right. Maybe I should give you this one as you try. Haha. Yeah, I think I'm going to give you that one, assign this one as a you try, and I would like to just talk about this last one. And actually graph it, okay? So I want you to think, because we've done this one before, this number 10 really is number 6, if you think about it, or number 7. Where is it actually? Yeah, really it is number 6. The reciprocal of number 6, that's what I meant to say. Really is the reciprocal of number 6, which I didn't write. Actually, I'm missing here. The equation of the reciprocal is y equals 1 over 1 plus 3 e to the negative 2t. That's the logistic curve, right? So this one is just the horizontal, not horizontal, vertical stretch of it, if you can think about it that way. Times 8 means that you're stretching it vertically. So if you thought about what that graph looked like before, remember that it was the logistic curve, that's what we call it now, but now it's been stretched to 8. vertical stretch of 8 instead of y equals 1. And when t equals 0, let's find out the y-intercept. When t equals 0, we're going to get 8 over 4, which means that this passes through 0 too. And that's what this logistic graph is going to look like. All right, so I wanted you to be able to see that. Once you start to see that, you can think, oh, this is what the graph looks like. All right, so let's do y prime. Let's do what we came here to do. Y prime is, because it's 8 over something, I'm going to think of it as the derivative -8 over something square. -8 over something square. What's the something? 1 plus 3 times e to the -2t. The derivative is -2 times e to the times 3 e to the -2t. Be careful. That's how I'm going to write it. That's how I'm choosing to write it. All right, next thing I want to point out, notice again, negative times negative means the whole numerator is a positive quantity. And we have 3 factors now, a, 2, and 3. So I'm going to break it up, instead of 2 fractions like before, I'm going to break it up into 3 factors. All right, the one thing I noticed is there's no 2 on my original equation, so the 2 is just going to be out there on its own. It's going to be 2 times. The 8 is right there, so I can say 8 as one of the numerators, 8. And remember, I want to break up the squares on the denominator as factors of each fraction, like we've done in the previous problems. And now that we've already factored out the 2, we've already factored out the 8, we're just missing this expression right here, which is 3 e to the -2t. Give you a moment to process that. Hopefully you're okay with that. And notice that this is 2, this is y. So then y prime is 2 times y times some fraction. Again, we gotta be able to solve for the numerator and the denominator. So I'm gonna do a little bit of algebra here, and we get that 1 plus 3 e to the -2t is 8 over y. Be careful, it's not 1 over y like before, it's 8 over y. So then it's 8 over y here, and visualizing the -1 gives us 8 over y minus 1. And we're going to multiply, what do you multiply this fraction to get a 1? It's y over 8 times y over 8. So this turns into 2y times, remember that this is a 1, no longer need to write that, but let's distribute that to the numerator. We're going to get a 1 minus y over 8. And that is as advanced as you're going to see of a logistic equation. But being able to graph this is not too difficult either. This is also a parabola. Also a parabola. What makes this equal to 0? A 0. And remember, it's a parabola with respect to y prime. Or with respect to y, I'm sorry. It's y prime versus y. When y equals 0, what makes this equal to 0? When y equals 8. Do the algebra. And it's concave up or concave down? Concave down parabola. Therefore, the maximum happens when y equals 4. When y equals 4. The maximum slope occurs when y equals 4, and that should not be any surprise. Look, y equals 8. We said that it was going to be like halfway. When y equals 4, that's where you have the maximum slope of this graph, at y equals 4. Right there. Well, hopefully you enjoyed this exploration of the logistic curve and logistic derivatives as much as I did.